The first thing you want to do when you approach the HPLC is check the solvent. That's really, really important. We can never let the solvent run dry. It needs to always be well above the level of that little white thing on the bottom. If it's close to even like a third to the bottom, maybe even below half, you need to notify me or a mentor. We cannot let the LC run dry. It's not that it would just mess up the runs. It can also damage the instrument. So check both solvent A and solvent B. Now when you're making up LC solutions, you want to make them in whatever your gradient is starting in. In this case, I'm at 80% A and 20% B, so I want to make it up in that. If you're just using 0.1% formic acid, you can start in that. To load your sample, you're going to open the door and pull out the appropriate lettered tray, and then place your sample in the position. Pay attention to where the numbers are on each tray. Make sure that you close the door. The instrument will pause when you open the door, and it will not run again until you close the door. To get started, make sure that the software is open. It should be open, and you should just leave it open. It's called Excalibur, and the icon looks like that. Now when you first start up, you want to check to make sure that the instrument is okay. So I've done this kind of zoom in here. Each of the devices should say ready to download. It's a good idea to pay attention to the status of the devices over here on the status page, because that should change when it's running. And if you come up and it's already running and you're queuing up behind somebody, you can sort of check that out, and that can give you an idea of what's running. These icons up here can switch you back and forth between this map, the road map view, and then what you're going to work in most of the time is called the sequence view, and I've clicked on it right there. You can also watch data come up in real time if you click on this real time view in the upper left. You can also select the instrument setup here to set up methods, and you can select the sequence view over here at this icon as opposed to that little icon in the upper left. You really don't want to start from scratch, so I've set up an example sequence for you. So you want to go ahead and open that guy up. Now you're not going to use that as is, it's just a template for you to build off of, and we'll talk about the important parts of the sequence that you'll need to change to your liking. We'll do a quick zoom in here on the sequence typing. The first thing is the file name. What are you going to name this thing? The second thing is the path, and that's when you record this data file, where is that going? And that should be your folder. The next thing is the method, and then the position, and that tells it, the robot, where to go in the tray. So give it a reasonable name, keeping in mind that you always want to run a blank before your sample. So your first run should be either what we call a cleaning run, or it's going to be a blank. And I typically use the vocabulary, if I'm running my unknown, then my first run would be unknown blank to indicate that's the blank for my known, and the second one would be unknown. And then if I found out it was lidocaine, then this would be lidocaine standard blank, or lidocaine blank, whatever the standard blank, and then the next run would be the standard. That is, we don't need to run a shutdown run. I've got this in here. Don't run a shutdown run. Just set it to go to standby. I'll show that to you later. Now the path, you're going to want to set it to where your data folder is, and that'll be a folder with your name on it. So make sure it goes there, otherwise it'll sort of go. And there's a trick here. If you're going to put the, you can always just do this over and over again, but you're going to have the same path probably for everything in your sequence. So you can highlight these rows here, and you can go to edit and say fill down, and it will fill up that sequence for you. That's a nice little shortcut, so you don't have to do the same thing over and over if it's the same thing. Oftentimes the path will be the same, and a lot of times too the method will be the same. Then the method is how you're telling the instrument to run, how you've sort of coded the instrument to run. There is an example method for you. There are a couple example methods actually, and that's a nice place to start. And later on we'll talk about if you want to tweak the method to change something to get better chromatography or change your mass spectrometry, how to do that. So we're going to run the same method for all these guys. We're going to say fill down. Again, please ignore that I've got shutdown in that last slot. You don't need to run a shutdown. Matter of fact, don't run a shutdown. Run a standby. And then for position, I paid attention to where I put my samples. It is critical. It is critical that you put the right position. If you put in the wrong position, the instrument will hang up. It will put up an error message that says, I didn't find that vial. And if it's in the middle of the night, then it will just keep pumping solvent away and potentially run out of solvent by the morning, because it's just pumping solvent away, waiting for a message from you that's not going to come because it's Saturday night at 3 a.m. So make sure that your positions are right. Put them in here and then double check them. Make sure that your positions are right. The consequences are pretty significant. When you're done, go ahead and hit File, Save As, and you can make a comment here to help you remember what this sequence was. I would always save all your sequences because it's like a record of what you did. And that comment can help you. You can just write what you did and what you were working on. And then you're going to give this sequence a name and save it in your folder. Now, instruments are going to be pretty particular about file names. You want to think as instruments as close to coding. Do not use special characters. Don't use slashes, periods, open, close, parenthesis. Just use letters, numbers, dashes, and underscores. A lot of times you can't even use spaces. When you're ready to go, you're going to hit Actions, Run Sequence. Now, there's a little bit of a change here. I should say standby. And this one I have it on. It needs to go to standby after you're done. Make sure that standby button is pressed. So you want it to say go to standby after run, and then you say OK, and then you're all set. Now we're going to pay attention to, I'm going to zoom in here. Now it's not saying ready to download. It's saying that it's getting ready to run, and then it'll start to say running and waiting for contact closure. And then you'll hear the auto sampler doing things. And when the auto sampler actually injects the pump, and the mass spectrometer will change from waiting to contact closure to running. And then you should be running. If you come over and it seems like the instrument should be running, but they're both waiting for contact closure and doing that for a long time, there could be a problem. Also, if the LC is running and the mass spectrometer says, there we go, just switched over to running, it just injected, and you actually hear it inject if you're standing there. Most of the time, you'll just be queuing up behind other people. So if you click over to the Queue tab, you should see your stuff loaded up in that Queue tab, and you can see where you are in the position. All right, so after we've got the data, let's talk about how to look at it. Usually you can just click on it over here if the computer's set to open it by default, and this opens what's called Qual Browser. We'll zoom in a little bit here. And that's going to bring up the LC view on top, and by default, the mass spectrometer view on the bottom with that green, that thumbtack green on the bottom. And wherever I click up top, that's going to bring up the mass spectrum in the bottom. And we're running electrospray ionization in the positive mode, so I expect to see the M+1 ion. Okay. Now, if I change that thumbtack up here, I can manipulate the LC, the chromatography, and I can do things like tell it to, instead of averaging all the stuff to, or instead of putting all the stuff together in what's called a tick, I've switched it to, over there I switched it to base peak, and that will clean up a lot of the noise a lot of the time and give us a cleaner chromatogram. But once I've got that green thumbtack, you saw me click it there on the mass spectrum below, it'll bring up whatever mass spectrum I click. I can also target a specific mass. I can show me a chromatogram for a specific mass. And here I'm going to put in, there's that little gross peak at the end. I put in the mass that corresponds to the mass spectrum in that peak. And so you see that second chromatogram there now. I really only see that it really highlights that second peak that came out. I'm actually not sure what that is. That's some kind of contaminant, but that lets me see really where that is. Now if I add the mass range for the peak of interest, the thing that I'm looking for, then it gives a really nice chromatogram where it's only showing the signal for that specific ion. This is a low resolution mass spectrometer, so just ignore the decimal places they give you there. All right, so if I want to modify a method, I can get it in a couple ways. I can work in the sequence view and go to the method file, right click and say open file. I can also go to the instrument setup. Now when I open a method, well, let's show you that instrument setup deal. Go to the roadmap view and you can click instrument setup, And it takes you to the same place, but you'll have to go to File, Open, and open that specific method. So if your chromatography is not working or you want to change something onto mass spectrometry, then you need to alter the method. All right, and there are pictures on the side. There's the pump, and when you click on the pump, the thing you're most interested in is there's the mass spectrometer. You're probably not going to mess with the auto sampler, so get familiar with the mass spectrometer and the pump icons. Okay, now with the mass spectrometer, one of the things that you want to pay attention to is the actual runtime, because the mass spectrometer runtime needs to match the LC runtime that you're interested in. You don't want the mass spectrometer recording for longer than it's supposed to, but more to the point, you don't want your LC run to not be done and the mass spectrometer cuts off. So the time that the mass spectrometer is recording for needs to be about the same. You want to make sure you're in positive mode. You want to make sure that your mass range covers all the masses that you are interested in. Usually we go from 100 to 500, and that covers all the drugs in the drug cabinet. But if you're looking for something at 700, you're not going to see it if your upper mass is set for 500. If you're looking for something that's at 84, you're not going to see it if your lower mass is set to 100. So with the LC, when you're playing with the pump and you're playing with the LC flow, you're manipulating the time, the %A, %B, and the flow rate. Now, odds are the flow rate is going to be the same the entire time, so that row is going to be the same. But the way that you're going to shift the gradient is you're going to tell it what %A and what %B it's supposed to be at a certain time. So it's not uncommon that we make 0 and 2 minutes the same, or 0 and 4 minutes the same. And that means we have a hold where we're holding for a certain %B, and we're going to go from low %B to high %B. So here we've programmed in a hold for a little while up front at a low %B, and that helps get a lot of the junk off before we start doing our gradient, and we ramp the gradient. And then we're also going to program in a hold at the end there, where between near the end and the end, it's at the same %B, so it holds at that %B. Now, after you're done with your gradient, your analytical gradient, and you're like, okay, this is what I want to see my stuff, you have to program in a re-equilibration. You have to program in a re-equilibration, because if the instrument is a really high %B, it won't know that it's a high %B, and it can't just instantly switch over to a low %B to run the next run. So you have to program in that re-equilibration, or your next run, the retention time will shift, because the %B will be slightly wrong for the run that comes after. So you always need to sort of program in that re-equilibration. How steep the ramp is very much affects your chromatography. How high the ramp goes, where the ramp starts, all those sorts of things are going to pretty significantly affect your chromatography there. Now, with the mass spectrometer, again, make sure that your acquisition time matches your chromatography time. Ignore the re-equilibration. You don't care about seeing what happens during the re-equilibration. So I cut the mass spectrometer off before the re-equilibration starts. And make sure that you save your method. Again, you can add comments if you want. Okay, one of the methods I have set up for you is essentially MS1, and the other one is a data-dependent method. So this is if you want to run MS, you need to first add a scan so that you get one that's just straight up MS. Now normally you could say, all right, I want you to focus on this specific ion. So if I was doing cocaine, I'd write in 304 and say, so scan to a full MS, and then in scan 2, take in the 304 ion and fragment it. That's what I have it programmed to do now. So it would scan check 1 just does regular LCMS, MS1, and scan check 2 would say just look for 304, which cocaine has an ion of 204, and fragment it the whole time. If there's no cocaine in there, that scan will give us nothing. That's what we would call a targeted scan, where we're looking for something that at mass 304. Now, there's a cool trick called data dependent scan, where we can click on this box, and that means I'll let you choose software. Every time you see a new peak in a mass spectrum, I want you to isolate that peak and do MS fragmentation on it. And that can be really cool, because you can just run something that you don't know what it is. You're not targeting it. And you really just click that data dependent box there. The default settings are really good. You don't need to modify the settings, and that will do that. So let's look at some of that data dependent data, or some of that MS-MS data. So our MS1 spectrum looks a little fuzzy here. You need to right click here and click on auto filter, and you see there are actual several different runs within that run. And the first one is a straight just mass spectrum. And if we click on that guy, we see that we have the M plus H ion, the MS1. And this is heroin, so it has a molar mass of 369, a nominal protein mass of 370. But if we click up here, we can see that in that other scan, it found heroin and said, okay, I did an MS-MS of that heroin. I'm going to get rid of these other ones by unchecking their boxes. I'm going to pay attention to the M over Z 370 MS-MS and then the MS1. That's all I want, because I just want to see my MS-MS for heroin and my MS1. Okay, so there we go. We have the big junky one on top that has all the scans on top of each other. And then on the bottom, we have our nice MS1. And in the middle, we have our MS-MS. So let's talk a little about what MS-MS is. We have this fragmentation spectrum. And what we have is we start off with heroin. And then when it isolated it, it only let in mass 370 ions, and it smashed it with gas, and that led to this fragment. It also led to this fragment in green, and it also led to this fragment that I've sort of highlighted in blue here. So we got these multiple fragments, and that fragmentation spectrum is much more of a fingerprint. That's saying more than, oh, it's just a thing that weighs 369, and we can actually search this guy in the library there by right-clicking. And in that way, through the fragmentation spectrum, we can get that category A data for heroin. Now, we're always going to compare this to a standard. We don't just look at the library. So the workflow here would be, we could run that data-dependent scan, and we would get the mass spectrum, and we would have a pretty good idea of what it is based just on the mass, because we subtract one, and that's the nominal molar mass. But then we can look at the dependent scans and see the MS-MS for each one. We can search those, and then if we think we know what it is, we go to the drug cabinet and get the standard for that, and then we rerun and we compare the MS1, the retention time, and the MS-MS spectra. The big thing is, does the MS-MS spectrum for your stuff match the MS-MS spectrum of a standard? That is what we're turning in. So the library is a really good way to point you in the right direction, but you do not point to some other people's library in court. You always compare with an in-house standard.